So we are talking about radius and interval of convergence again. You don't necessarily have to write that whole paragraph, but maybe you want to summarize it. So we've already found out how to find the radius and interval of convergence in 10.4. We've done that before. We apply the ratio test, set the answer less than 1. What we haven't discussed yet is what's going to happen at the endpoints on an interval. We always had our interval with less than symbols, never a less than or equal to. Now we're going to see, is it possible for us to have equal to symbols as well, and not just less than, like we always had negative 10 is less than x is less than 1. But it's possible maybe we have negative 10 is less than or equal to x is less than 1. Or negative 10 is less than or equal to x is less than or equal to 1. So we can also test the endpoints, but we needed all 6 tests before we could, well, there's probably even more than 6 if we count p-series and geometric. We needed all the tests before we could start checking the endpoints to see whether they should be included or not. So the basics of it is the same as what we did in 10.4, and then we're going to have some extra steps after. So since we know most of the process already, we're not going to have a lot of setup. We're going to mostly go straight to examples. So find the radius and the interval of convergence of that series. So our first step is to apply the ratio test. Remember, when we do the ratio test, we absolute value it, which will be nice because when we absolute value this, what's going to disappear? All I heard was the negative piece. The negative 1 to whatever. Well, this just alternates between negative and positive. So when we absolute value this, it's just positive 1, which when multiplied by stuff doesn't matter anymore. So when we absolute value, that's nice because it gets rid of that negative piece and we don't have to worry about it at all. So with the ratio test, we still have a limit out front. Limit as n approaches infinity. Everywhere we see n, what do we replace it with? N plus 1.
Well, right. Thinking of something else. Okay.
I thought you said plus 1. But. And then we divide by the original. A lot of the time we've been going straight to flipping it. I just want to make sure we know that we do actually have to flip it because we're dividing a fraction. So this would become, I'm going to distribute that 2n as well. X to the 2n plus 2, 2n plus 2 on the bottom times absolute value. 2n over x to the 2n. So when we were doing the ratio test, it was great if we had exponents or if we had factorials, because those would cancel out nicely. The 2n and the 2n plus 2, those are not going to cancel out. But that's okay, because usually we could apply L'Hopital's rule after. But first we had to cancel out the exponents. What do we get when we work with those exponents? If x to the, you subtract,
Squared.
so x to the second. 2n plus 2 minus 2n cancels out the 2n's. So we have just x squared And then we didn't really need to keep the n's themselves in the parentheses because, in the absolute value, because the n's by definition are positive numbers. Then count from 1, 2, 3, 4, so they don't need to be absolute values because they're already positive. So actually we can't apply L'Hopital's rule, but we could do our special clever form of 1. What's our clever form of 1 we can multiply by? 1 divided by n. And I can't apply L'Hopital's rule because I have that weird piece out front.
Do you do 1 divided by 2 then? In this case?
You could. So we get absolute value of x squared. If we do 1 over 2n, we'd have 1 over 1 plus 1 over n. Now what happens when we plug in infinity into n? This piece here is 0. So our limit is x squared, absolute value of x squared. So now we took this and set it less than 1. So right now I can tell my radius of convergence. If x has a coefficient of 1, then this side is my radius of convergence. Or sorry, yeah, radius, that was the right term. Sometimes we had to rearrange things. If that had said 2x squared, we'd have to divide both sides by 2 first, and then say the radius of convergence is 1/2. If there is a coefficient out front, we have to take care of it and make this a coefficient of 1, which again we practiced in section 10.4. And then how did I make this an interval of convergence? Get rid of the absolute value. So we would split it onto both sides. Now this kind of has a special, because we have x squared, we haven't really worked when it was x squared before. What happens when we square something? Every number that we square will come out positive. So I actually can drop the absolute values before splitting up the interval because it's already positive. But then when I square root it, I still get plus or minus 1 as my answer. So I still get this -1 is less than x is less than 1. It's thinking about it a little bit differently, but we get to the same place anyway. So when we have squared, we could either square both sides before we absolute value it and say absolute value of x is less than 1 and then split it up, or we can drop the absolute value. The reason we can't put -1 on the other side before we square root it is because what's the square root of -1? I. So we just have to do one of the two options. Either drop the absolute value bars because we're already squared, or square root both sides, and then do your interval. But we end up at the same place. We have our interval from -1 to 1. So with this interval, we already know everything inside the interval converges. If I plugged in 0 for x, it would converge. If I plugged in 1/2 for x, it would converge. But we need to check the endpoints for convergence. So we need to go all the way back to the original series. -1 to the n plus 1, x squared over 2n. Was it from 0 to infinity or 1 to infinity?
It was
Is 1? Okay. And we need to replace x with the endpoints. So we're going to have to do this twice. We have to check -1, and we have to check +1. So we have to check the endpoint -1 by taking that series and replacing the x, not the n, because our interval is all about that x value. And we have to do it a second time and check +1. So all the stuff up above is stuff we've done before. This is the new information. So we have to use any of our tests. At this point we could use alternating series, we could use ratio, any of our tests that would work to prove that this converges or not. It could diverge. If it diverges, then when we write our interval, we leave it as just less than. If it converges, we'd write our interval as -1 is less than or equal to x is less than or equal to 1, depending on which ones converge or not. So looking at 1 to the 2n, what do we know about 1 raised to anything? It's still 1. So really this one, I can kind of simplify it. So let's try the alternating series test. This is an alternating series. We need to see if, when I got rid of the negative part, are all my terms positive? If I plug in to here, would they all be positive? Yes. If I got rid of the negative part, 1 over 2n, that would all be positive. We have to check if they get smaller. We have 1 over 2, 1 over 4, 1 over 6, over 8. Sorry, I was about to sneeze. Am I getting smaller? You did not. And then I have to check that my limit approaches 0. And this one's an easy one. What happens if we plug in infinity right away? 0. So it passes all 3 parts of the alternating series test, and this converges.
So you do that for both endpoints.
Yep, we've only done it for one endpoint.
Right,
Now
you
we've
just
got to
do
go back over here.
Alternating series test.
Now, luckily for us, I'm going to split this up a little bit. If I have -1 squared to the n, is that the same as -1 to the 2n?
Yeah.
What's -1 squared?
1.
Positive 1. So really, I have 1 to the n over 2n. And what's 1 to the n? 1. So again, this works out nice for us because I end up with the exact same series. That will not happen every time. It just happened in this case. I've already proved the other one converged, so what do we know about this one? It converges. I don't have to go through the proof again, because once we simplified, they were the same thing. So this doesn't affect your radius. What this does affect is your interval. My radius is still 1. My interval -1 less than or equal to x less than or equal to 1. If one of the endpoints had failed, we don't have to write the equal to part. If one of them had diverged, we would only have this or this. And if both had diverged, we'd leave it how we had originally. So this depends on whether we converge or diverge. But for this particular problem, they both converged. So not a whole lot different, but we do have that added step at the end where we have to test those endpoints.
So it changes if they're less than or less than.
Yep, that's all it changes. Okay, so I'm going to have you guys try one. Sorry, I was going to make this bigger. It's easier to see.
Yeah, that's my
So the book lied to me. Okay, so I'm not going to show the ratio test part. We've practiced that before. Your interval should have been 2 to 4. What's your radius for sure? 1. That doesn't change no matter what. So we need to plug in 2. And we need to plug in 4. And check both of these. So this one gives us -1 to the n over 2n. And this one gives us +1 to the n over 2n. I don't know, I wrote that like an exponent here. And what do we know about +1 to the n?
1.
Might as well just be 1. So the right side, we have to check using integral test or limit comparison test. We tried, while I was paused, a couple of different tests because the book lied to me and said this converges, but it really diverges. So either test we try will prove that this diverges. If we tried the integral test, the integral from 1 to infinity of 1 over 2n, we have to put the limit out front, limit as b approaches infinity. I'm going to pull out the 1/2. And then what's our integral of 1 over n?
It's negative n to negative.
Nope, that's the derivative of 1 over n. The integral.
Negative n. No. Wait.
Ln.
Sorry, what?
Ln. We're trying to differentiate because it's nicer for our brains. But really the integral is ln
Oh.
of n evaluated from 1 to b. You know, there's a lot to remember in calculus. There's just a lot going on. Ln of b minus ln of 1. Ln of 1 might as well be 0. Well, it is 0. I don't know why I say might as well be. Ln of 1 is 0. What's going to happen if we plug in infinity for b?
Oh, infinity.
Gives me infinity. So this series diverges. Sorry, I freaked out before. Just the book doesn't make many mistakes, and usually it's in the homework problems, not in the main part of the text. So I was like, wait, I swear this diverges. It screwed with my brain. Okay. This one is an alternating series.
Yeah, the science section. Robot squirrels. And snakes.
Cool.
Okay.
This one's alternating, so we can just use the alternating series, which is easier. We know this is getting smaller. We used it last time. I guess 1 over 0, though, doesn't really work. But the next term, 1 over 2, 1 over 4. So it gets smaller. It converges to 0. So this is convergent, but with an alternating series test, it doesn't necessarily tell me I'm absolutely convergent. We know for sure it's conditionally convergent. How would I check and see if this is absolutely convergent?
Take the absolute
Absolute
Take the absolute value. What's going to happen when we take the absolute value, though?
Then
It's the one we've already checked. So this is only conditionally convergent. So I could ask you to tell me, where are we conditionally convergent and where are we absolutely? So we just should make sure to specify conditionally I'm convergent from 2 less than or equal to x less than 4. The less than 4 will never change because it was divergent. Or I could write this in interval notation. But if I ask for absolutely, and they love doing little tricks like this to you, absolutely, where one word changes the whole question. If it was absolutely convergent that they ask you about, then we wouldn't have any symbols, any less than or equal to. It'd only be less than. So we just have to make sure we remember the difference between conditionally and absolutely.
which is
Conditionally means it converges when that negative piece is there. Absolute, but not if you change that negative piece to a positive. Absolutely means it'll converge whether you have a negative piece or a positive piece there. We have the more math definition in the notes before these ones.
so it can conditionally diverge or converge.
It can conditionally converge. It cannot conditionally diverge. Notice the right
Right.
side is the same for both of them. It's only the left side that changed because the right side diverged, so it just doesn't have a symbol there. So we have one more example. We'll try and get through it pretty quick. I didn't realize we were so close to the end.
I can get it.
So this one just shows what can happen. This shows what can happen if you're divergent from the beginning, I believe. Or no, if you converge everywhere. So what will cancel?
The n as like 1 goes to 10n, and the 10n to the n goes to 1.
Well, those two combine together to become something.
Right. And
Nope, the n's will disappear.
then, or 10x.
So it would just be
Yes,
10x.
10x, okay.
Not 10x.
It'll just be 10x on the top. What about the factorials?
It would be
N plus 1 on the bottom. So now, if I plug in infinity, no matter what is going to happen?
it's going to be
And then
Why do you say 0?
because it's just a number on the top and then infinity on the bottom.
Number on the top, infinity on the bottom. This definitely goes to 0 no matter what x is. So remember, when that happened, I didn't even touch anything that time. Okay? When that happened, that means we converge all the time. This converges everywhere. So it converges for all real numbers, which means I don't need to check my endpoints. And also it means we don't really have a radius of convergence because it converges everywhere. What if I had done this process and I get infinity no matter what? Diverges everywhere except where the x piece would become 0. So it could converge for one point only and diverges everywhere else. So homework tonight. Okay. 528. Through 45 odd. And this one does specify absolutely or conditionally in the instructions.
You've officially done it. That was 2.5 pages of notes for you.